Okay, so in this video I'm going to go for a quick demonstration on how to use the hashcode and the equals methods within Java. So these are two methods that are out of the box within the object package, but what we need to do is essentially override these methods to use their full functionality. So what I'll do, I'll go for a quick demonstration as well as a justification on to why you would actually do that in the first place anyway. So let's say we have two students and they're both in a music class. Oh. So if I go into new class and then let's say this is called music. Public static void main string args curly bracket. Get rid of that bracket. Okay, good. So what I'm going to do for starters is create a student object. So student, let's call this guy stud1 equals new student. And when I create the object instance, I'm going to pass over some values. Let's say I'm going to pass over his name along with his ID number along with another value. Don't know what that is at the moment, but I'm sure I'll think of it. So what I'm going to do here is create the actual class student and then go back to music. It's going to ask me to ask the constructor and then I'll get rid of that. Okay, so what we've got at the moment is that we're creating a student object stud1, and then when we do create that, it's passing over the string value as well as two int values. So when we create the object, let's this string equals string, and then this int I equals I, and then this j equals j, and then just make all these private ints, private string. Very good. So when we create the object, it's actually storing it within the actual object itself. If I go back and let's say I actually want to create a second student, so copy and paste stud2, and what I'm doing here is passing over, when I create the object itself, I'm actually passing over the same values that I am when I create the first object. So if I have a look, first thing I want to look at is the hash code. So if I do a sys out, oh, there it is, stud1, and then I can look at the method hashcode. So when I run that, it actually brings back a hashcode. Essentially is a large integer value that's uniquely identifying the object that resides within the Java memory when you run the program and create the object. What I'll do now is that if I run the program again, it's going to give me a new unique identifier every time I run it, and it could be the same as the time you just ran it as well. So if I go and create a new system out, but instead this time I'm actually looking at the stud2. When I run that, you can see that when I create the two objects, even though I'm passing exactly the same values when creating the object, the actual unique identifier of the object differs, or the hash code differs. What I need to do to use the hash code to its full functionality is to ensure that these values are only considered when creating the unique identifier for the object itself. And what I need to do, and how I need to do that, is to go back to the student class and override the hash code. So within Eclipse, I can go in and click generate hash code and equals. And if I do that, assuming that I've already declared my values anyway, it will pick it up when I click on the value and it says, do I want to generate the hash code and equals for these values here. So if I click OK, what it will do is populate and do all the hard work for me. So you can see here, this is the hash code, and here is the equals. And they tend to go hand in hand as well. So if I were to modify one, I'm more than likely going to modify or override, let's say, the second method. So to have a quick understanding of what's actually going on here, when I create the object and then call the method hashcode, it's actually picking up this method that's overriding the existing out-of-the-box method. So what it's doing here is picking up a prime number and then passing that against all the values that I've imported in when I create the object itself. So it's using the I plus the results times the prime number is equal to the result. And then on the second line, it's doing exactly the same, but it's using J as the value, the integer value that I get when I populate and create the object. And it's also using the string value of Daniel and then returning the result back to its initial call. So if I run this time, you can see that the actual unique identifiers are exactly the same now. And the reason for that is that it's just using these values to uniquely identify the object that's created. And what I can do here, actually, if I remove this, let's just remove that for the meanwhile. Give that a save. If I go back, let's do a sys out. Let's say stud1 equals stud2. So what I'm doing here is checking if it's a true or false to whether stud1 object equals stud2. And as you probably would have guessed, when I run that, it's actually returning false because of the unique identifiers. If I go back and then regenerate the hash code and the equal sign, when I run the equals methods, it's actually taking a conditional understanding on a multitude of things, but basically what it's doing is to ensure that the objects that you create and you're comparing are actually the same when you run this program, when you run this call. So now if I run this, it should come back, and it does, as a true. So these objects are now exactly the same. If I create a new object, for instance, let's say stud3, and then let's call this guy Daisy. It's a very popular man name. And he's been there for a while, so his unique identifier is 1. And then let's say this, and then let's say this is another value. So if I look at the hash code, for instance, if I run that, you can see that the hash code is actually different because of the attributes that I'm passing. If I look at the comparison between the value between the objects, let's say stud2 is compared to stud3, and then let's say stud1 is compared to stud3 as well. So if I run that, I can determine whether or not the objects are the same based on the overriding equals and hash code methods. So that's it. So the benefit really to there is that we can use the hash code or the object or unique identifier of the object in a multitude of fashions. So we can, once we've created this object and now it has a unique ID, we can see whether or not we've created this object before, and if so, we can do a conditional understanding around that. We can use when we create the object itself and we have a unique identifier, we can use that unique identifier and populate associated values to that. So let's say if we want to create a hash map and we want to, the student now has a number of different classes that it associated to. Let's say now he's took a fascination with maths, for instance. We can then associate the characteristics and values associated to this value here. So a number of ways you can use it, but more importantly, the reason why we override the equals and the hash is to ensure that the object unique identifiers remain the same. Okay, thanks for watching.